Hello, in this video we are going to see a brief introduction to software for indifferent curves and budget constraint. Well, from the software point of view, if the function is differentiable, in Spanish is diferenciable, then if you can calculate the derivative, the partial derivative, then you can use, if you have available MATLAB, you can use this function fmin con. This con stands for constraint, and basically this is what the function that you are going to use, and then what you get is the first parameter gives you the x and y or whatever variable you are using, the solution, and this second parameter give you the maximum utility function that you find subjected to this constraint, and the algorithm that you can use for this function are all of these that you can set before you use this fmin con function. So you can Google this function in MATLAB and you will find a lot of information how to use it, but I'm going to do a video when I have time. This is the function that I used to do the previous simulations, and then if the function is not differentiable, then I mean you can't find the partial derivatives, then you can use this function of MATLAB. GA stands for genetic algorithm, so in this case you can use this function that is available in MATLAB. The execution takes much longer compared to the previous one, but the advantage of this option is that the function doesn't have to be differentiable. I have recorded a video about this, which is in Spanish, and I will try to do as soon as I can an English version, but I will leave you the link for the Spanish version anyway. Okay, I use mainly MATLAB. Well, there are other alternatives with advantages and disadvantages, but if you are not a computer guy, then you might find MATLAB like the easiest way of programming. Well, I should make a separated video about that. Anyway, summarizing what we have seen up to now, the main approaches to solve indifferent curves and budget constraint is from the mathematical point of view. The most common approaches are substitution and Lagrange. Substitution is quite simple. If you want to maximize this function subjective to this constraint, then you first solve for y, isolate y, and then you substitute this y here in the objective function, and then you just maximize, like, because you are going to have only x here, you are going to have only one independent variable, then you maximize this function that has only one independent variable, and you just maximize calculating the derivative equal to 0, and then you solve for x, and that's it. Then the value that you get for x, you put it here, and then you get the y, and then you get the solution. So this would be substitution in a nutshell. If we use Lagrange, then we have seen that the basic concept, the foundation, is that you put the gradient of the utility function and force it to have the same direction of the gradient of the constraint function. And we are going to see that if you have two constraints instead of one, then what you have to do is to put the gradient of the objective function as a linear combination of the gradient of the first constraint and the gradient of the second constraint. I have already recorded many videos of this case with more than two constraints for the case of linear function, what is called linear programming. I will try to make these videos in English, but I will leave here the link just in case you want to have a look at it. And then if you use a software to solve this, not only because you get a graphical representation, but also because there are cases in which you cannot apply neither substitution nor Lagrange, then the main approaches to solve this kind of problem with the software are, if you use MATLAB, this and this, and as soon as I can, I will do a separated videos for these 4 cases. Okay, that's it. I will be recording videos normally on weekly basis, so if you can subscribe to my channel, and then you will get new videos. Okay, that's it. Thank you very much for watching, and see you in the next video.